Hi guys, I hope you're doing well. This is lesson 6. It's kind of a review really of some of the things we've been doing and just adds on a little bit more, but it's really not too complex. So hopefully this will help solidify some of the things that we've gone through thus far. And so it's called solving basic trig equations. There's a bunch of steps here and I'll go through them once we do an example. But really, we're just solving for the angles that we were talking about before. So as I said, this would be good review. So if we look at the first one here, it says solve the following for theta on a given domain without the use of your calculator. So here's our domain. Theta is between 0 and 360. And we've got this ratio for sine of theta. So it's root 3 over 2. So there's a couple things, and it doesn't really matter where you start with this, but obviously, this is a positive ratio. So I'm just going to zoom in a little bit here. So this is plus root 3 over 2 as opposed to negative root 3 over 2. So what that means is, if you remember the cast rule, it tells us which quadrants we're going to be in. So if you draw out the cast here, and I've got this being here, I automatically know because sine is positive, it's going to be in 2 of the quadrants. So the 2 quadrants are going to be here and here because this is where it's all are positive and this is where sine is positive. So I know automatically that I'm going to get angles that are in this quadrant, so I can draw a quarter of the bow tie in each. And if you want, you can label the 90. And so that's the first part of the question. Again, you don't have to do that as the first step, but you can. Second part is related to this alpha thing. The alpha, remember, is my related acute angle or my reference angle. And so it's the one that's less than 90 degrees that's going to be in all 4 corners of this bow tie. So the way I figure that out, so if I rewrite sine theta equals positive root 3 over 2. So recognizing the root 3 and the 2 is key. And so you know that from that one triangle where we have 1 root 3 and 2, the angle is going to come from that. And hopefully you're familiar with it now to know, but if not, I would just draw this out and figure it out. So the shortest side, which is the 1, has the smallest angle opposite. And so, so the 1 is opposite the 30 here. So I'll just draw that back in. And then the next smallest side is root 3, which gets the next smallest angle opposite to it, which is 60. And so if you think of sine, I always think, okay, so it's the opposite side, so opposite over hypotenuse. So that means if it's opposite root 3, that means that has to be 60. So what we do is we say, okay, then that means that alpha, the related acute angle, must be 60 degrees because sine of 60 is root 3 over 2. So now with our diagram and with this alpha, we know that actually because it's in the first quadrant, the all quadrant, really theta 1 is 60 degrees. That's this angle here. And then the second angle is not too hard to get. It's just going to be wrapped around here. So that theta 2 is just 180 minus the 60. So you end up with 120 degrees as your second angle. And so not too complex. Just remember, it's always going to be relative to 180 when you're doing this, unless it's in the 4th quadrant, the one where cast is positive. Okay, let's try another one. So again, hopefully this is just review. So this one says tan theta is -1. So I'm going to do the same order as what we did before, where I know that tan is negative. So I'll just draw this out. So I got tan being negative. So ask yourself, and hopefully you're able to answer this, where is tan going to be negative? In which 2 quadrants? And so hopefully you recognize that's one of them and that's the other one. And so these are my 2 quadrants where tan is negative. So I can automatically draw my angles in there, or my triangles. And I can automatically put in alpha, the related acute angle, there. So what I want to find is this angle, theta 1, and this angle that's wrapped around, theta 2. So before we do that, we need to find alpha. So if tan tan theta equals -1. This one's a bit trickier because the -1 or 1, often if it's sine or cos, that's one of those special cases. But with tan, this comes from that triangle that's 1, 1, and √2. And that's the 45, 45, 90 triangle. So if you think of tan being opposite over adjacent, you can get 1 over 1, which works out to our alpha. So one thing you can do here, I'm just going to erase this. You can go and say, okay, alpha, if you did have a calculator, which I would like you to do this without one, you can do the inverse tan of the positive ratio of 1. That's going to actually work out on your calculator to give you this. But you should be able to do that without a calculator. So you get tan 45 is equal to 1. But what we have is the -1, and that's because, again, it's in these two quadrants, the S and the C here. So I can figure out what theta 1 and theta 2 are. So theta 1, because it's there, it's always going to be 180 minus alpha. So 180 minus 45. So that's going to be 135, oops, that. And then theta 2. Because we're in this fourth quadrant, it's going to be related to 360. So I take 360 and I minus the alpha. And so I get 360 minus 45, which is 315. And so there's my two answers. Okay, next one's just a little bit different from what we've done in a couple ways, actually. The first is if you look at the equation, I've got this equation here where it's not set up as a sine, cos, or tan with equal to a ratio. So I've got a couple steps to do for algebra. Second part here is that the domain where theta exists is different. It's not from 0 to 360. Now they're saying it's from 0 to 720. So we'll deal with that in a minute. The first thing we can do is we want to isolate for sine theta. So I want to move everything over to the other side of the equation that's not theta. So if we start to do that, I've got √2 equals, and I'll move the 1 over, so it becomes +1. Now I want to get rid of the √2, so I need to divide both sides by √2. So I end up with this. So now this is very familiar. It's something we just basically did, and we can think of this again as being a positive. And so I can think of that. If you don't need to draw this, you don't necessarily have to, but I think it's good practice too. So again, sine is positive up here in the top. And so I can draw this in. All I need to do is figure out alpha. So in this case, 1 over √2. Again, if I go back to this triangle here, 1 over √2, oops. 1 over √2 relates to 45 for sine. And so alpha is going to be 45 degrees. So I'm just going to draw in my theta 1. Theta 1 is the same thing because it's in that first quadrant. And then theta 2 is this one. So that's 180 minus 45, which gives me 135. So that gives me the two angles that are between 0 and 360. But now we have to think of it as being between 0 and 720. And it doesn't make it that much more complex, but there's a couple steps we have to do. So basically, these are where you get those coterminal arms. So basically, coterminal means it has the same terminal arm. And so remember, if this was 0, it could be also 360. It could also go all the way to 720. And you could do that the same with here with 90, which would also be 450, and so on. And so what we have to do is we just simply say, okay, what I want is I'm going to go wrapped around all the way to here. So I'm going beyond 360. So I'll call that theta 3. So theta 3 is just going to take my original answer, which was 45, and I add 360 to it. If you remember, that's how we do coterminal arms. So it's pretty simple, just a concept really, that you're repeating these things. So we end up with 405 degrees. So that's that one. We still have to do the same for theta 2 where we go, and this is where the drawing gets a bit confusing, but I'm going to wrap all the way around to that arm, and I'll call that theta 4. So I just take 135 and I add 360 to it. So if I do that, I end up with 495. So I end up with 4 possible answers for theta because my domain was expanded to 720 degrees. And so not too complex, and this is kind of the beginning of solving trig equations, and as I said, most of it's reviewed. Next class will be a bit more complex when we do it, but I do have a little quiz for you to try as well. Okay,